name is Binti Azman with matrix number 147111. I am a 4th year student from Biophysics program under School of Physics. This assignment is done individually by me, and in this video, I would like to give a presentation about one of the well-known physicists, Stephen Hawking, and his famous study about Hawking radiation. Little information about Stephen Hawking. Stephen Hawking was an English theoretical physicist and cosmologist. Despite of his motor neuron disease, which gradually, over decades, paralyzed him, he still managed to give a huge distribution in science world. You know, he is very famous about his prediction about Hawking radiation. Before we jump deeply into Hawking radiation phenomenon, it's important for us to know at least the basic understanding about black holes. What is black hole? How black hole exists? Let me explain. Black hole existence first discovered by Albert Einstein in 1916 with his general theory of relativity. When a huge star dies, it leaves a small but dense remnant core when it's quake. If the mass of that core exceeds around 3 times the mass of our sun, the force of the gravity will outweigh all other forces, creating a black hole. A black hole is not just an empty space. In fact, it is a great deal of space packed into a very small area. Well, just imagine what happened when a star was many times larger than our sun being squeezed into a sphere. The result is a celestial object is created, and its gravitational field is so powerful that not even the light can escape it. So, I think everybody know why the black holes named as a black hole. It is because they are completely dark. I think I did a pretty good job making you understand about black hole. So now, let's move on to our main topic, Hawking radiation. Astronomers had a very basic grasp of black holes in the early stages of scientific investigation into them. It was once thought that black holes don't emit any type of energy. However, it is all changed in 1974 when Stephen Hawking came up with his theory about black hole. He proposes that black holes were not really black. In fact, empty space isn't actually empty. Although empty space contains no mass, no particles or quanta of energy, the quantum fields which define them still exist in the vacuum of space. He also claimed that black holes can emit radiation. Stephen Hawking theory stated that the mass of a black hole could become energy, which could then be radiated away. Why he came up with such prediction? Well, he formulated this theory by combining insights from quantum mechanics and Einstein's general theory of relativity. Sadly, in early discovery of Hawking's theory, it is not really accepted among the scientists, but thankfully, it has finally gained acceptance and popularity and become known as a groundbreaking discovery in the field of black holes. Stephen Hawking proposed that Hawking radiation is commonly described as the result of twin virtual particles known as particle and antiparticle that naturally emerge from the vacuum being separated by gravity. How is it happening? According to the principle of quantum mechanics, for every particle throughout the universe, there exists an antiparticle, which I call them as twin virtual particles just now. These particles always exist in pairs and continually pop in and out of existence everywhere in the universe. Normally, a particle-antiparticle pair will quickly annihilate each other as soon as they met and stop to exist almost immediately after their creation. That being said, things change slightly near a black hole's event horizon, the barrier beyond which nothing can escape its gravitational pull. One particle may fall into a black hole and the other one may escape if a virtual particle pair suddenly appears very near to the event horizon of a black hole. The object that enters the black hole really has negative energy, which is analogous to pulling mass and energy away from the black hole. Hawking radiation. The other particles of the pair that escapes the black hole has positive energy and is referred to as Hawking radiation. However, it is not clearly established what an evaporating black hole would actually look like. The Hawking radiation itself would contain highly energetic particles, antiparticles, and gamma rays. Such radiation is invisible to naked eye, so an evaporating black hole might not look like anything at all. No matter what, it is best not to go anywhere near an evaporating black hole, as it would be dangerous gamma rays and energetic particles, even if you couldn't see its existence. So for the conclusion of Hawking radiation, an evaporating black hole would be detectable from Earth only when it evaporated within the solar system or close to our star near us. This is a purely theoretical concept and quite a complicated one to prove mathematically until Stephen Hawking finally found this theory. So we must be thankful to him as he discovered this theory. So I'm Aida Hanim with Azman signing off. That's all from me. Thank you. Bye-bye.